All right, welcome back, everybody. Welcome back from spring break. A little intro music there of Stone Cold Steve Austin. Back when he played for when he wrestled for the WWE. Um, so hope everyone had a good spring break. I know I did. Definitely got away, um, away from, just away from, certain things that we normally do, and just spend time with my family, my girls and stuff. It's been pretty a lot of interesting stuff. The girls are getting a little bit more involved in getting outside and going on hikes and stuff, and they really enjoy that. They also are getting into some video games with Zelda and Animal Crossing, and they love that stuff. So, but we've been pretty active getting outside when it's nice out. And one big thing happened for me is just yesterday. My brother and I and my nephew, he's your age, he's in seventh grade, we won Warzone in Call of Duty. So we won. We just started playing. I've only played like 5 6 matches, and so we ended up winning the Warzone. We were all three alive at the very end, so it was pretty cool. It's pretty cool to have that as a group, just kind of doing that stuff. Um, and it's just fun to play. So, but we're gonna get back into our math stuff. I hope you guys are having an awesome time from spring break, and I'll leave a question right here for you guys to say, hey, how was your spring break? But we're gonna get back into math. We're gonna talk about classifying quadrilaterals, classifying triangles, and how many degrees are inside a triangle. And it seems like a lot, but it's not a whole bunch because this is mostly identifying what types of quadrilaterals that we should know. Identifying triangles by the angle or by the sides, and then we have how many degrees are inside of a triangle. Wednesday. Wednesday is when we'll be doing it algebraically with the interior angles of a triangle, solving for a angle. So the quadrilaterals, um, this is where you want to take notes, so you can pause anytime you need to and take notes. Quadrilaterals are any four-sided shape. Okay, so they have four sides. It's a four-sided polygon. Okay, easy way to remember that is a quad. A lot of people call four-wheelers quads. Okay, so they're riding their quad and so forth. That means it's a four-wheeler. It's got four wheels. It's a quad. Okay. I think the first car was called a quad cycle or something like that. It was something because bicycles had two wheels and it was like quad cycle. Um, and a car had four, basically bicycle wheels. They didn't have car wheels back then. When I first started making cars, they used basically bicycle tires. So four-sided polygon and it's quadrilateral. Now, we're going to break this up into like a web. We have a kite, which means it has two um, consecutive sides that are congruent. So two pairs of consecutive sides that are congruent. And like what you normally think of as a kite. So that is congruent with those, and these two are congruent with that. So that kind of splits that up. It just has two consecutive sides that are congruent. In other words, they're the same size. And so these sides are congruent with that. That's it. Another one that comes off here is a trapezoid. That means it has one set of parallel sides. Okay, which you guys are familiar with. It's kind of hard to write sideways here. And trying to make sure I keep everything on this board. It's a pretty good size board, but it's not exactly um, as big as a board at school. So, normal trapezoid you guys see. Then you have the isosceles trapezoid. Something like that. That means these two are exactly the same size. So, isosceles means that they are two sides or more congruent. So, isosceles trapezoid. Then we have a parallelogram. Okay, so parallelogram means that all sides are parallel. So two sets of parallel sides. So um, any type of parallelogram will do. So typically you might think of a rectangle or whatnot, But you could even have something that's kind of like a diamond shape or a square shape. But this means it has two sets of parallel sides. And usually what comes off that is a rhombus and you have a rectangle. So, you know why the rhombus was always late? Because it got on the wrong bus. But a rhombus has four sides that are congruent. It does not have four 90-degree angles. So it just has four sides that are congruent. So something like that, where it has all four sides are congruent, but not 90-degree angles. So uh, so we say those are all. So we could also do a parallelogram like this. Parallelogram like that. Two sets of parallel sides. Okay, so that means these are parallel and those are parallel. So rhombus has four sides that are congruent. Remember these little hash marks mean that they're congruent. A rectangle, we all know what a rectangle is. Now the only thing that means has to have a rectangle is a quadrilateral. It has four. Okay, so it has four 90-degree angles. Okay, so it has four 90-degree angles. That's it. If it satisfies that, it is a rectangle. Then we put these two together. That is a square. Okay, so a square is, we know, has four congruent sides and four 90-degree angles. Put 90 angles there. That little box means it's 90 degrees. So, and technically, even a square is technically a kite. So these can actually kind of go together. I'm not really looking for that. When I ask you to classify a shape, I just want you to give me the most specific version of it. You don't have to necessarily give me every single thing. However, it could be a select all question. So this is the hardest part. A select all question they could or possibly ask, identify everything. And a lot of times, even with some of the other stuff in the state, even though technically a square and a rhombus is a kite, they won't classify them as a kite. So a lot of times this is kind of like the redhead stepchild of the thing. It's kind of left alone. It's just usually they don't include it, but technically it is. So technically that is a kite, but usually they leave it alone. And if they have a select all question, if I asked you classify a square, well, and it was a select all question, you would have to pick square, rhombus, rectangle, parallelogram, quadrilateral. It's kind of, have to select everything that is true about it. Okay. Um, so, it's kind of like its family tree here, like everything about this and above. Um, so if you see a square, just call it a square. But you should know that, hey, a square is a rectangle. It is a rhombus. It is a parallelogram. It is a quadrilateral. It has four sides. So that's your notes on quadrilaterals. We're going to talk about our notes on triangles. All right, so triangles are classified by their sides or by their angles. So by sides, okay, if you classify them by the sides, you have a equilateral triangle. Okay, now an equilateral triangle, let's put right here. Equilateral triangle has a word, basically it sounds like word equal. That means all sides are the same. Okay, so all sides are congruent. So an equilateral triangle generally kind of looks something like this, but all sides are congruent. They're all the same just by the sides. If you're classifying just by the sides, okay, that's an equilateral triangle. If you classify once again so by sides, if we have two or more sides are the same, that's called isosceles. So, I think I spelled that correctly. Let me look it up real quick. I always have a problem. I always want to know if there's two S's there or not. Let's see here. This is why Miss Crane doesn't teach language arts, but isosceles. No, I spelled it correctly. So I spelled it correctly. Isosceles, isosceles triangle. So what that means is a triangle that is two or more sides are congruent. So two or more sides are congruent. So generally it looks like it's hard to write on this because I'm moving on me and everything. Basically, something like that. Now, technically, a equilateral triangle is isosceles, believe it or not, because the definition of isosceles is two or more sides are congruent. So therefore, equilateral is isosceles triangle. But two sides, generally we just do two sides, isosceles triangle. And the last one here is scalene. I don't know if I have room down here really to do it. So I'll put it right here. So C, scalene. Okay, so scalene is going to be no sides are congruent. So okay, so no sides are congruent. So we might have something like that. So no sides are congruent. So none of the sides are the same size, and that's not what it is. So it's just no sides are congruent. Um, so those are the sides. Now we have one more set of notes to do here. And still triangles. We have a little bit, actually a little more. You can also classify triangles by their angles. So triangles, once again, and classify them by their angles. You know what? I think I'm going to wait to the 180 degrees on Wednesday. We're just going to classify the quadrilaterals and triangles and be done with it. But triangles, we're going to talk about the angles. We're going to classify them by the angles. And in case you guys haven't heard, I believe they have canceled state testing for this year. So that is a huge relief for you guys and just for me. Just I like to teach, so I can just kind of just teach you, which is nice too. So and not have to be stressed out about getting everything in. And definitely a different time of the year this year. But we can classify triangles by angles, and so you have an obtuse triangle. So an obtuse means it has one angle greater than 90 degrees. Sorry. So obtuse is one angle is greater than 90 degrees. So if it has just one angle bigger than 90 degrees, it's obtuse. That's it. Okay. So basic easy one. We have that one. So this is obtuse triangle. Also, it's scalene. If you look at it, that is not big as that. Nothing's congruent there. Okay, you can make an obtuse isosceles one if you wanted to. So let's see if we can make one. So let's say that are the same size. So that's bigger than 90. So we have obtuse scaling. I'm sorry, obtuse scalene and obtuse isosceles right there. So you classify them. That's by obtuse triangles and by their sides. There. So B here, we have acute, which means there's one angle less than 90 degrees. So, an acute one, less than 90 degrees, one angle. Remember, when we talked about angle size earlier in, I think, Unit 7, acute little angle is less than 90 degrees. So, definitely something that looks like a equilateral triangle has all angles are less than 90. It's so hard to write on this thing. So all angles are less than 90 degrees, and so that would be a acute triangle based off its angle measures. And then last one, but not least, is a right triangle. That means it has one angle of 90 degrees. Okay, so one angle of 90 degrees. And so we have a right triangle. And this could be, you generally see that box there. Remember that red box means it's 90 degrees there at that corner, at the elbow, at the vertex. So this is 9 degrees, and so this one would maybe be isosceles. I don't know if that's the same size, but it might be right scalene. But that would be a right angle. So it's a right triangle based off of its angle measure. So um, that's it for notes. One last thing is that triangles have to equal 180 degrees. Okay, that is the sum of all interior angles. So if we added up this angle, this angle, this angle, it has to equal 180 degrees. This angle, this angle, this angle has to equal 180 degrees. This one, this one, this one, 180 degrees. This one, this one, this one, 180 degrees. Now quadrilaterals, and you might want to bring this back and maybe put it in there with the quadrilaterals. But quadrilaterals has to equal 360 degrees. Okay, so 360 degrees is the sum of all the angles inside of a quadrilateral. So like a square. Square has 490-degree angles. Well, 4 times 90 is 360 degrees. So even like a quadrilaterals have to equal 360 degrees. So all the interior angles of those is 360 degrees. And it's really, really weird. As you get bigger and bigger polygons, you get bigger, bigger interior angles. And they get huge and they get very big. All right, so there's even a formula for that. But we're not getting into that right now. The weird thing is, and I think it's fascinating. One of the things I just love about math is how these things, just how cool it is when you get back to a circle. A circle is an infinite number of points around a center point. Okay, and that is 360 degrees. So which is pretty neat. It's 360 degrees, but yet other polygons, even just 1 point smaller than a circle, is going to be huge. It's going to have a huge interior angle measure if you add all those up. But a circle has 360 degrees, which is the exact same thing as a quadrilateral. And if you think about it, if you cut a square up into 4 spots, so if we took a square, we cut that up, and we put the corners to each other, what you're getting is this. It's opened up. And so, and technically, yeah, you can go all the way around. You could actually make a circle out of that. So, which is pretty neat. And so that goes about 360 degrees. So we cut that up and put the corners together, right? So we get an XY coordinate grid is what we get. So once again, it's one of those things about how things interact and how things intertwine mathematically. It's pretty neat. So this will be an ed puzzle, and you will answer some questions at the end of this. And then tomorrow you'll have another quizzes. You'll have quizzes over this stuff. Wednesday we will be getting into the interior angles of triangles and quadrilaterals and trying to do those and just getting the missing angles. Okay, so we'll get the missing angles and then we'll turn it up to be the next part after that will be algebraically solving for a missing angle inside of a quadrilateral or triangle algebraically. Okay, making equations out of it, solving it algebraically, and then we'll get into what makes a triangle. We might do, well, yeah, we're definitely what makes unique triangles. So side stuff, and that's the only one that's actually a con assignment is the one in 7th grade with the what side lengths make a triangle. And so we're getting into that. We'll also, I'm going to throw in here in this unit just because there's no state testing and stuff like that. We don't have to have a review and stuff like that. I'm going to throw in some other eighth grade material stuff. That's just Pythagorean theorem. Since we're on the last unit, we'll kind of put some things in there that kind of all meld together, which will be good. So answer these questions. Remember, guys, complete those. You'll get points for them. But I hope everything's going well, and I can't wait to maybe see you or see you next year at some point. It'd be nice, but it's important for everyone to be away from each other and not spread the virus, and hopefully we can return back to normal as soon as possible. So take care, guys, and I'll see you next time.